building defect is one of the major components of building problems that significantly needed attention. When a building fails to function as it should, we must immediately seek for the determination. The problem taking place depend upon a number of factors. Such effects include physical, thermal, biological and chemical. For instance, the black rust buildup is generally caused by the accumulation of materials on the surface. Heavy loads on the surrounding ground, from trucks and heavy buildings as well as small subterranean tremors and minor earthquakes, can affect the foundation directly by creating holes and cracks between the stones, which breaks the mortar between them. Due to high humidity and temperature, cracks start to occur in the plaster. Salts are considered one of the most important deterioration factors for porous building materials used in BEIRUT houses, such as sandstones and lime mortar. Forces from surrounding large buildings and towers is transferred to the foundation of the BEIRUT house, causing imbalance in its foundation. In summer, the temperature and salt effects on the external plaster causes cracks and exposures to the load-bearing walls. The crystalline formation of salts is known as efflorescence, which is generally whitish, powdery or whisker-like crystals on the surface. Because these materials are characterized by porosity and these salts undergo processes of crystallization from within. In winter, the historic building is exposed to moisture and rain. This could lead to the deterioration at the top element of the cornice, which result in horizontal gaps at the top of the link between them and the wall. This leads to rainwater accumulation on it and seep into the wall. The underground foundation is exposed to subsurface water, which is an important factor affecting material. Water enters the walls from the ground and spread in the building materials of the walls by capillary suction. The effect of moisture, salt crystallization, and degradation lead to large cracks in the ceiling and falling plaster, as well as infected timber beams. The BEIRUT explosion of August 4, 2020, resulted in devastating damages on BEIRUT houses. This caused the triple arcade columns, windows, and structural elements to fall, putting the building in critical condition. It also allowed load-bearing walls to dislocate, hence endangering the stability of the structure. Long-term wood exposure to high temperatures leads to disruption in cellulose molecules and compounds. When wood is exposed to elevated temperatures, changes can occur in its chemical structure that affects its performance. It loses its internal water content, which leads to change in its dimensions and to the appearance of cracks and breaks in wooden joints, where then the wood becomes fragile and weak. Steel and iron have been used in the repair and reinforcement of timber, which may have decayed due to rot or deformed because of overloading. Because of the risk of condensation on metals, iron and steel reinforcement should always be visible and open to inspection. This problem could be overcome when the use of stainless steel elements is often applied with the repair of existing timber-to-timber connection. During intervention, the remaining windows and doors are removed and replaced by wooden diagonal supports, and wooden propping bracers are laid onto the outer walls for support. Interior scaffolding is placed to support the weak ceiling. The connectors are wooden in order to protect the ground and timber elements from raw steel pressure. The scaffolding is also used for maintenance, plaster removal, and repairs. Air drains offer some potential to control dampness by encouraging evaporation to occur at the lowest possible level. The evaporative zone can be lowered by excavating a trench against the building and exposing the bottom parts of the walls. However, the water drainage method is implemented at the bottom of the walls from the outside and aims to drain the groundwater and remove it from the base of the wall by drilling a trench along the wall from the outside, placing a PVC pipe with holes, then filling the trench with large stones at the bottom and gravel at the top. On the ground level, the scarf joint timber girder method is used to repair timber beams. The rotten joist end is cut off, removing quite a bit of timber that isn't rotten, including the edge molding, and an angle cut is made to the bottom of the beam to allow a new part to be bolted on a good distance from the fulcrum point. On the other hand, joist repair plates technique is used by treating the end of the joist, discouraging any further rot. L-section galvanized steel plates are used with standard coat screws, screwed onto both bottom edges, which are secured at the end of degraded timber girders. Repairing deep and large cracks are done by relinking and packing the edges of the crack by installing wooden keys of 100 cm length on the width of the crack, with 50 cm between each one drilled inside the wall to reach the middle. Interventions to improve the connections wall to floor. It is achieved via the insertion of ties, confining rings, bolts, and steel anchor plate. Intermediate floors are strengthened by firstly removing the gravel sand and the existing wooden planks, then installing new rectangular-shaped bolted planks laid by a perimeter metal frame. Another method involves removing existing tiles, gravel and planks, then applying 2 layers of bolted squared planks connected in the middle by a pair of metallic belts, FRP strips in a diagonal X-shaped overlap. This method increases the stability and endurance of the floor. Debris and leftovers are loaded on trucks for recycling. Weakened walls are supported by interior bracing cables connected from the outside by wooden planks and galvanized metal plates. Balconies are then reconstructed on site using 3 large 4-cm pieces of marble, glued and then connected by a layer of carbon fiber, and then topped with another layer of 4-cm marble, making it an 8-cm balcony instead of the traditional 4. The balcony is then carefully raised and placed on the existing corbels. Repairing the triple arcade facade is done by initially salvaging the remaining marble column pieces and placing them on a newly constructed semi-wall. Steel rods are then inserted inside them and attached to new pieces. Diagonal wooden bracers are in place for support. This measure restores the arcades to their original form. The pitch roof is repaired by firstly replacing the damaged existing battens by new ceiling lining battens, then installing a layer of insulating RLF arcing. And finally tile battens are added in order to later augment the red tiles. Strengthening the walls is done by reshaping straight surfaces with a saw blade and engrave with a fine chisel and a hammer, depending on the finish of the adjacent original surface. In addition, fixing a reinforcement of galvanized mesh or synthetic fiberglass on the surface to be relayed with a mesh greater than 2 cm improves the integrity before applying the finishing plaster. Finally, the new lime plaster is applied and new window shutters and doors are installed.